Yes, my students, how are you? Quite well. Okay. Now see here, today we are going to solve fourth problem of practice set 3.4. Okay? Now see here, in figure 3.58, segment RS is a diameter of the circle. This RS is the diameter of the circle. Okay? With center O, point T lies in the exterior of the circle. Here T lies on the outside of the circle. Prove that RTS is an acute angle. RTS is an acute angle. First, we will construct here. First, we will join here this R with T. Okay, we will join it, and then after this, we will join here this T with S. Okay. Let this RT intersect the circle at point P. You have to consider it. It's not given, but it's intersecting at point P. Now we will do the construction here. We will join this P. We will join this P with the S. Yes. Okay. This is our construction. Now see here, as we join here this R with T and T with S, and here P with S. Now see, if you will see here, this will be the right angle. Why? Because RS is the diameter, therefore this part RPS is a semicircle, and angle inscribed in semicircle will be 90. It must be equal to 90. Okay? Now see what will happen. First, this is of 90 as per the inscribed angle theorem. Now see here, because here SPT, it's making the linear pair, or you can say it is a angle on a line here. This angle will also be equal to 90. Then what will happen? As this angle is of 90, in triangle SPT, if one angle is in triangle SPT, if one angle is of 90, the other two angles should be acute angle. Therefore, here PTS will be an acute angle. Then instead of PTS, we can write here RTS, the same angle with the different name. Therefore, this RTS is an acute angle. This we will write here. Okay. Now first we will start from the thing which are given. First here we will write the thing given. What is given? Seg RS is a diameter. Okay? This is given here. Now the construction. What is construction? Join R and join point R, point R and S with T. Let's consider segment R T intersect circle at point P. You have to consider it because it's not given. You can take any alphabet. Okay, and then after this join point P with yes. This is the construction. I have done it. Okay, now after this the proof will be here, here. The proof is now see, for the proof we will start from the things which is given. Seg RS is a diameter. Okay, it is given. Okay, now see, as per construction we will write here I measure angle RPS is equal to 90, and for this we will write here the angle inscribed in semicircle. Okay, angle inscribed in semicircle. This is 1, this is 2. Okay, now see, this is of 90 as per. Now next we will write here the angle P SPT. Here measure angle SPT will also be 90 by making linear pair. Okay, they are linear pair, angle at a line. Okay, therefore this is of 90. Now we will write here. Now see here, as this is of 90 Therefore, in triangle SPT, angle SPT is equal to 90 from second. Therefore, the other two angles of triangle SPT will be an acute angle. Why? Because in a triangle, if one angle is of 90, then the other two angles should be acute angle. Therefore, here we can write that angle PT yes is an acute angle. RTS is an acute why the same angle with different names. This is the same angle, means you can say PTS or RTS. Okay, this is the proof. Okay, is there any problem? No. Okay, the next is prove that the fifth problem, prove that any rectangle is a cyclic quadrilateral. Now see here, we are going to draw a rectangle here. Suppose this is our rectangle. Suppose this is our rectangle. Here is let P, Q, R, S is a rectangle. Okay? Then what happens? You know that all the angles of a rectangle are of 90 degrees. All the angles are of 90 degrees. Therefore, now see, here we will prove that the sum of the opposite angles of quadrilaterals are supplementary. And as the opposite angles are supplementary, then from the converge of your cyclic quadrilateral theorem, this quadrilateral is a cyclic quadrilateral. Okay, we are going to first we will write here let quadrilateral PQRS is a rectangle. Now after this, therefore each angle of rectangle is of 90 degree. Okay? Therefore, measure angle SPQ plus measure angle QRS is equal to 90 plus 90 because all the angles are of 90 degree. Therefore, here this is 180. Measure angle QRS. Okay. Now see, we will write here the sum of these two angles is equal to 180. We will write here as sum of opposite angle of rectangle is supplementary therefore quadrilateral P therefore rectangle PQRS is PQRS is a cyclic quadrilateral. Okay? Because sum of these two angles, we show that sum of these two angles is equal to 180, that is, as sum of opposite angle of rectangle is supplementary. Rectangle PQRS is a cyclic quadrilateral. Okay?